Welcome to this explainer. We're going to take all those class notes and textbook chapters and boil them down into the ultimate study guide for descriptive statistics. We'll find the story hidden inside the numbers, so you're ready for pretty much any question they can throw at you.
Okay, so that stats exam is on the horizon. And you know that feeling when you're just staring at a page of raw data? It's just a pile of numbers, right? A total mess, until you find the tools to make sense of it all. And that's exactly what descriptive statistics is for. It's about finding the story that's hiding in the data.
And to unlock that story, you've got two pretty powerful toolkits. On one side, you have the numerical summaries, the actual numbers, the calculations that give us really precise values. And on the other side, you have the graphical summaries, the pictures, the charts and graphs that let us see patterns in a single glance. We're going to get a handle on both.
So first things first, we have to find the heart of our data, the center, what the pros call measures of central tendency. It's really all about figuring out, what does a typical value in this dataset even look like?
Now, the first one, the one you've probably known forever, is the mean. It's just the average, plain and simple. Super easy to calculate, but, and this is a big but, it has one major weakness. And trust me, your lecturer absolutely wants you to know what it is.
And there it is, the weakness your lecturer warned you about. The mean is, well, it's kind of sensitive. A single crazy high or low number, an outlier, can basically grab the mean and pull it way off, giving you a totally misleading idea of the center. And that's why we need another tool in our kit.
And that tool is the median. The idea couldn't be simpler. You just line up all your data points from smallest to biggest, and the median is the one sitting smack dab in the middle. It's literally the middle ground.
And this right here, this gives the median its superpower. It is robust. Since it only cares about what's in the middle position, it couldn't care less about those extreme outliers. It just ignores them. And that makes it the perfect tool to use when your data is skewed, which, don't worry, we'll talk more about in a second.
Oh, and speaking of the median, okay, you have to pay attention to this. Your lecturer pointed out a critical correction from the class notes that you absolutely have to know for your exam. This is one of those little details that can make or break a question.
Let's be 100% clear on this. If you have an even number of data points, ignore any other formula you might have seen. The correct way to do it, straight from your lecturer, is to find the two values in the middle and just average them. That's it. Commit this to memory.
All right, so finding the center is just part one. Part two is figuring out how spread out or how clustered the data is around that center point.
This is where variance and its way more intuitive cousin, the standard deviation, come into play. They basically tell you the average distance of every point from the mean. Is the data all bunched up, or is it spread all over the place? But just like the mean, they are sensitive to outliers. So for skewed data, we need that robust alternative again, the interquartile range, or IQR. It measures the spread of just the middle 50% of your data, totally ignoring the extremes.
Okay, you know the drill. Pay close attention here because, just like with the median, your lecturer flagged another really important clarification, this time about the variance formula for grouped data. This is another classic exam trap.
I know this looks like a mess of symbols, but it's a very common trap. It all comes down to the order of operations. On the left side, you square the midpoint first, and then you multiply. On the right, you do all the multiplying and adding first, and then you square the final total at the very end. They are not the same thing, and you've got to know which is which.
So we've got the center, we've got the spread. The next piece of the puzzle is describing the overall shape of the data. Is it nice and symmetrical, or is it kind of lopsided?
Skewness tells us exactly that. You can see it in the diagrams. A symmetrical distribution is that perfect, pretty hill in the middle. But if the data has a long tail that stretches out to the right, we call that positively skewed. If the tail goes left, it's negatively skewed. And this shape gives us huge clues about which statistical tools we should be using. And look, this brings us right back to what we were saying earlier. It all connects. As your lecturer pointed out, in a skewed distribution, those outliers in that long tail will pull the sensitive mean right along for the ride. And that is precisely why for skewed data, the robust median gives you a much better, much more honest picture of the true center.
There's actually a pretty cool way to wrap all of this up, and your notes mention it. It's called the 4 moments of a distribution. Think of it like a 4-step checklist to describe any data. First, the mean tells you the location. Second, the variance tells you the spread. Third, skewness tells you about symmetry. And fourth is kurtosis, which just describes how sharp the peak is. Together, those 4 numbers give you a complete statistical picture.
Okay, my brain hurts from all those formulas. Let's switch gears and talk pictures. Because honestly, sometimes seeing the data is way more powerful than just calculating it.
Now, this is a classic point of confusion, a favorite for exam questions, the difference between a histogram and a bar chart. So here's the crucial point. Histograms are for continuous numerical data, stuff you can measure. And their bars must touch to show that there are no gaps. Bar charts are for distinct categories, like favorite brands, and their bars are separated.
And this histogram of shipping times is just a perfect example. You can see the whole story instantly. The center is obviously where the tallest bars are. You can see the spread by how wide the whole thing is, and you can even see the shape. Notice that little tail stretching out to the right? That tells us it's a bit positively skewed. It's all right there in one picture.
So, after all that, how do you know which tool to pull out of your toolkit? Let's put this all together into one final, simple takeaway that you can use to nail your exam.
And here it is. This is your cheat sheet straight from your lecturer's advice. It's this simple. If your data is symmetrical, you use the mean and the standard deviation. But if your data is skewed, you absolutely must use the robust alternatives, the median for the center and the interquartile range for the spread. That's it. That's the key to getting it right every time.
Because at the end of the day, this stuff isn't just about passing a test. It's about having the power to look at a sea of information and find the truth, to spot the patterns and to tell that story clearly and with confidence in a world that is just overflowing with data.